So we will start with the first talk by Catherine Tessier. And Catherine, you have the ground. Thank you.
Okay, thank you very much, Raja and Mohamed, for inviting me to give this talk this afternoon. So good afternoon, everybody. So I'm going to focus on ethical questions, and to make it more concrete, I will focus on a particular European project that intend to put micro robots in a beehive. So this is the project, which is called Robotics. In fact, it started in 2021. And so you can see the aim of the project. We aim for, they say that they aim for a minimally invasive approach to affect large ecosystems in a positive way. That's the way they put it. We aim to regulate and also enhance the egg-laying activity of a honeybee queen by replacing her courtyard by a set of robots that feed and nurse her. Okay, so I will refer also to a paper some members of the project published recently in 2022. So in this, I'm not going to read all that, but in the description of the project on their website, you can see that they speak about a minimally invasive approach, a positive way, so to replace the courtyard of the queen by a set of robots to enhance her egg-laying rate. So the protein will inflow exclusively to the queen and not to the rest of the colony. And they say without robots, these two flows are practically inseparable in nature. So the effect is that the workers will engage in more pollen collecting, and they see three positive effects. This will positively affect plant growth, vegetation spreading, food and seed production. 2, this will in turn support animals as food. And 3, ultimately, enhanced pollination can also lower the competition that honeybees have for nectar with other wild and currently endangered insect species, etc. So they say that it's a novel method which the experimenter can vary these two foraging activities of honeybees in a controlled manner. That's what they say. Our special idea is that we can affect a whole ecosystem, potentially millions of plants, and in consequence, hundreds of millions of animals and other organisms by simply affecting one single living organism in a natural and non-invasive way with robots. Okay, so when you feel your the ethics self-assessment sheet, and when you focus on that particular project, the interesting point is that there are no humans involved, not directly at least. No humans, no personal data. But instead, animals are of course involved. So yes, that's research involved animals. But they are not vertebrates, and they are bees, that is to say insects. And insects, especially bees, are not an endangered species. That's very interesting. So insects, in fact, are not covered by the directive of the European Parliament and the Council of 22 September 2010 on the protection of animals used for scientific purposes. That's a very interesting point. So if we go further with the ethics self-assessment sheet, section 7, environment. So does this activity involve the use of processes that may cause harm to the environment, to animals or plants? Well, yes. probably. Does this research involve endangered fauna and or protected area? No. And the third question, well, the answer is not clear. Does this activity involve the use of substances or processes that may cause harm to humans, including those performing the activity during the research? So this is not clear because maybe as an indirect consequence, this activity might cause harm to humans. Section 8, artificial intelligence. So the answer is yes, because there are robots that are developed and they intend to use machine learning processes to learn how the courtier bees behave in the beehive. So back to ethics. So I'm going to focus very quickly on what ethics is not and what ethics is. So in fact, ethics is not the law, of course. So I've put here the GDPR, which is a piece of law that comes from sovereign authority. Okay. Ethics is not staff regulation. So I've put here the staff regulation for the European Commission civil servants. So staff regulation are rights and duties that come from an organization. And ethics is not deontology. Deontology is a code of conduct that comes from a profession. For instance, I've put here the European Code of Conduct for Research Integrity, which has been revised in June 2023, so very recent update here. Okay. So next, ethics has to do with morality and values. So morality, what is morality? It's in fact a set of rules and principles according to which one directs one's life and behavior. So it's considered in relation to good and evil. So it says what is right and what is wrong. It comes from society. Usually there is a social consensus on what is wrong and what is right. It can come from religion, from yourself. And morality is normative. For instance, it is bad to lie, it is bad to steal, it is bad to kill, etc. And ethics is also based, of course, on moral values. Values, it's something that is desirable, that you stand up for. Again, it comes from society, it comes from religion, yourself, etc. You can break a value, especially if you are in a situation of moral dilemma, and you have a decision to make in such a situation. You will have to certainly to break one or two values. So, what is ethics? So it's a thought, it's a reflection, which is personal or more often collective. And this thought is about human behaviors and the values that are based on. So ethics is an approach that aims to wonder about topics, situations, possible decisions and actions, and this takes place along the way. That is to say, you don't do ethics and then you stop and that's it. No, it has always to be on the way. So it's an approach that aims at behaving or acting at best. It's not the best, but it's at best in a specific context. And if you have to decide, well, ethics helps to decide about the right decision or action according to arguments. So arguments are very important in ethics. And those arguments are based on scales of values, moral values, of course. Therefore, ethics does not command, as for example, the law or morality, but ethics recommends. And most often, the ethical debate is based on conflicts between values. So you have several values at stake, several principles, and they cannot be satisfied at the same time. So ethical debate will will end with which value we prefer to satisfy to the detriment of which other ones. So in a nutshell, ethics is different from compliance, or at least in English. In French, it's not the same, but in English, it's more than compliance. So saying what should or should not be done is not sufficient. Ethics is a continuous thought, so it doesn't stop, that evolves all the time. Why? Because society evolves, science evolves, technology evolves. And ethics has to do with dilemmas, and I've already said that. So a dilemma is a situation where a decision cannot be compliant with all the principles, values that are involved. So you have to make trade-offs. So I've taken those sentences from a French report about ethics, and we are going to instantiate those sentences on the particular case of the bee robots. So ethics is a deliberation, always to be resumed, that must make the difference between the possible and the acceptable. We are going to focus on that first. Then we have new knowledge, and it complicates or shifts the scope of our questioning, often increasing our uncertainties. So we are going to focus on uncertainties too. So ethical reflection therefore requires us to question the principles that define the very notion of progress. So is progress a good thing or not? And according to what? And each time this progress is involved, we must critically analyze the certainties again and the convictions that underlie this progress. So this critical analysis must be based on the one hand on values, that's the deontological approach, and on the other hand on the most lucid possible assessment of the benefits and risks, and that's the consequentialist approach. And again, we have during this ethical process, we have to articulate the values with one another to find the best possible balance when they come into competition. So, ethics and robots in the beehive. So first of all, there seems to be a paradox in this project. Because on the one hand, this project, so the Robot Royal project, is designed according to some goals, which are the following: affect large ecosystems in a positive way, and result in the workers, the bee workers, having to engage in more pollen collecting, thus pollinating flights. Okay, so that's the goal. That are the goals. But at the same time, the project is likely to go against those goals. In fact, it is likely to the experiments, and even if it is put in the nature afterwards, it is likely to induce disruption of the hive. And more generally, it is likely to threaten pollination and food security, because in fact, there is a competition. The more you have domestic honeybees, the less you have wild bees. There is a competition between domestic honeybees and wild bees. So it may affect, of course, the whole environment, so pollination and eventually food security. So there are uncertainties about this project. Second point, the deontological point of view. So they say in the project, the ethics, one of the ethics point is to make the difference between the possible and the acceptable. So they say in the project that their aim is to design micro-robots replicating bees' behaviors, to put robots into the beehive in order to modify the bees' behaviors. So this is possible. Okay, technically speaking, it is possible. But is this acceptable? So this is a question. I have not the answer right now, but we have to raise the question. So is it acceptable to design micro-robots replicating bees' behavior? Yes. Is it acceptable to put robots into a beehive? That is more questionable. Is it acceptable to modify the bees' behaviors? That's questionable. And more than that, is it acceptable to conduct experiments with insects? And and they don't speak about the sustainability of robots. They don't speak about that. They don't focus about that. But that's a question too. Second point, question the principles that define the very notion of progress. So I have put here two principles: increase scientific knowledge in robotics, in ethology. Yes, okay, the project will increase scientific knowledge on robotics on the one hand and on ethology on the other hand. But what about the other principles? Protect, restore, and promote sustainable use of terrestrial ecosystem, halt biodiversity loss. In fact, it is one of the United Nations Sustainable Development Goals. It is the number 15 here. So what about this principle? Is it respected or not with this project? Then uncertainties. So critically analyze the certainties and convictions. So I have extracted here two small paragraphs from the paper I've mentioned before. So small group of robots operating in a honeybee colony, interacting with the queen bee, a central colony element, has the potential to change the collective behavior of the entire colony and thus also improve its interaction with the surrounding ecosystem. But that is not proved. Will it improve the interaction? And what does improve mean? We have another paragraph here. It is the first step towards a team of robots working in a biocompatible way. Is it really biocompatible? To study honeybees and to increase their pollination performance. Will it, in fact? Thus achieving a stabilizing effect. Will it be a stabilizing effect at the ecosystem level? So there are many questions here that are not, of course, discussed in the paper. Next point, the analysis of consequences or possible consequences. So we have to do the most lucid possible assessment of the benefits and risks. So as far as benefits are concerned, I will not focus any longer on that because there are many benefits that are described, so-called benefits that are described in the project itself and in the papers. So I will not insist again on that. But as far as risks are concerned, they are not questioned at all in the project or in the papers. So we have to consider the effects on bees, because maybe the robots will change the bees' behavior. Maybe some bees are going to be stressed. Maybe they will kill each other. Maybe they will kill the queen. Maybe they will become lazy, etc., etc. We don't know. And what about the robustness of robots? And what happens if robots fail into the beehive? And next, there are effects on environments. So what are the resources that are necessary to make and operate robots? And how it is dealt, how the life cycle of the robots dealt with? especially at the end of the life of the robots. And perhaps this project or this process will harm the surrounding ecosystem through the bees that will have a changed behavior. And it's highly probable that there will be other uses and even misuses of these micro robots. For instance, to use modified insects to modify ecosystems, or other uses, of course, of micro robots, especially in the military. So to sum up, I can cite here the recommendation of the UNESCO and Article 108. You can see that the AI researchers should be trained in research ethics and include ethical considerations in their design, products, and publications. Yes, everybody should be trained in ethical thinking. And in fact, ethics is not only a matter for ethics experts or ethics officers. It's a matter for everybody in science. And ethical thinking should always be associated with research projects, theses, etc. And every scientific paper should include an ethical discussion. It slowly begins to be mandatory in some conferences, but it's not a general point of view. And in fact, the last point that I want to make is that ethical issues are tightly interwoven with scientific issues. That is to say, an ethical issue can lead to new scientific developments and new scientific developments in new ethical issues, etc. So, thank you.
Thank you very much, Catherine. If there is one or two pressing questions, we have a few minutes. So please raise your hand or just speak up. I don't see any hands raised. Okay. I have a question, Catherine. So what you say is that we need this ethical reflections in any project, even some projects that apparently don't raise ethical issues, such, I mean, the one that you presented clearly in the beginning, it was very clear that apparently there were not so many ethical issues. However, there are actually a lot when you think about it, and many of them are related to uncertainties about how to understand the evolution of a situation or here an insect society when we tamper with it. Of course, it's not always easy to estimate this risk. Maybe by the way, Alan will allude to that. But what should be, in your opinion, a proper approach to actually cope with this problem about uncertainties? Mm-hmm. And especially when uncertainties are related to a dynamic system, such as a beehive. Mm-hmm. It could be also human societies.
Mm, yes, sure. Well, the main problem is that in that particular project is that the people of the project are in fact very certain about their project, and they don't question anything about what they are going to do and to propose. And so they don't even raise uncertainties at all. So the first thing, I believe, is to question the different scientific developments you are going to make, you're going to propose, and avoid being sure that your results will be such and such, because it's not sure at all, because it is research, in fact. So the first thing is to raise questions and to wonder whether those scientific developments will aim to the results that you are expecting or not. And in which way, of course. So avoid being so certain about the results that you're going to have.
Yes, questioning our own knowledge and our own certainties, of course. Any question? Okay, we are just on time, and I can invite Johanna to take the floor and share her slides.
I hope you can all see the slides.
Yes, perfectly. Thank you.
Thank you very much. Yeah, I'm actually, this is a wonderful continuation. I'm continuing the line, now moving from robotics in nature to ethical problems as they arise when we do social robotics. I am from the research unit for robophilosophy and integrative social robotics, as you mentioned. Raja, we have been working in a highly interdisciplinary setting for about 10 years, involving over 30 researchers from 12 disciplines. And as you can see from these disciplines, it's a combination of engineering disciplines, natural sciences, but in particular, humanities and social sciences. And my message for, just a second, for some reason, my screens don't work here. There we go. We have been working under the with the principle or under the slogan, when it comes to social robotics, we actually need to bring what Catherine called the possible and the acceptable, the can and the should, as closely together as we can. And we developed a new approach to how to do social robotics, a method for developing culturally sustainable robotics, where the many disciplines work together and try to discharge the enormous responsibilities that are on our shoulders when we develop social robots, try to discharge them together. We use a new descriptive framework and a specific method, and I will say a little bit about that later on. But my main agenda for today is somewhat provocative. I want to claim that anybody who needs the term human-centered seriously and takes him or herself really committed to the project of developing human-centered approaches to social robotics or simulatory AIs, then I want to say anybody, any engineer or team of engineers who tries to do that, you cannot proceed without having humanities and social science researchers in your team. That's the provocative claim I want to present for two reasons. First of all, social robots are not robots, as I will explain. Second, values which are at the center of the so-called human-centered approach are particularly difficult to track. So let me start. So when we decide, I hope that you all will agree that a social robot can be defined as a robot that can move in the physical and symbolic space of human social interaction, and is in fact also designed to exhibit some social cues in order to maneuver in that space of symbolic space of human social interactions. But that immediately implies actually that social robots are no longer robots. this is most palpable once we give these social robots a humanoid shape, and once we program them in order to exhibit certain familiar gestures. But also when you have zoomorphic robots, depending on the social cues that they give. So here you have Paro, the robotic seal. They engender real emotions in the people interacting with them. Here you have a picture from an experiment where a participant protected this robot by lying to a human being. So strikingly, social robots are not tools and nor things, because they actually activate the sociobiological mechanisms of human social cognition. There are the low levels mechanisms of motor resonance and perceptual resonance that are activated by robotic gestures. These are incidentally the ones that are particularly important for imitation learning. Then there are mechanisms of creating joint attention, the gaze cueing effect that can be activated by robots. And finally, we seem to be very prone to take the so-called intentional stance towards these robots, again, depending in particular on how they move and how they're shaped. But given that they send social cues, we are in general and in principle disposed to take the intentional stance, meaning we are disposed to ascribe to them beliefs, emotions, intentions. So whenever we design a robot for movement in social space, whenever we just give them social navigation skills, or just the skills to respond to verbal commands, we are actually turning them into a new and rather paradoxical type of being. So social robots say of themselves that they are no longer things or tools. They are artificial social others. These are the kind of scenarios that engineers are trained to address, the kind of technology failure that has to do with either physics or also the biological sphere that they are interfering with. But as Catherine's talk so nicely suggested, whenever we interfere with biological reality, it is already very important to take expertise from that domain into account in order to prevent, on the one hand, technology failure, but also in order to fulfill the best intentions that, of course, engineers bring to their enterprises. So when robots, however, enter public social space, technology failure takes on a new dimension. Once you know that it is the police robot that fell into the fountain, you realize that now you have sent a rather unintended symbolic message about the police. In a nutshell, the core problem with social robotics is the following. Whenever robots enter public interaction space, they are in the physical and symbolic space of human social interaction. But that is the most complex domain that we know. And safety consideration only address the tip of an iceberg, an enormous iceberg of problematic aspects. So social robotics, by its very design, requires interdisciplinary collaboration. I hope that so far you got an idea of the first part of the claim, namely that social robots are not robots. The second thing to keep in mind is that the human reactions to social robots cannot be predicted. So some of you might know Cynthia Basil's early design principle. She was saying that Kismet, her first robot, should be designed as if it were a socially aware creature with thoughts, intentions, desires, and feelings. Believability is the goal. Realism is not necessary. She did not, presumably, anticipate the kind of problems that we see right now already arising. The disruption level of these new social others in our society is currently unknown. After 15 years of human-robot interaction research, we still do not quite know what could be done to actually prevent humans to replace their human contacts with interactions with robots. As Sherry Turkle pointed out, the performance of connection seems to many people connection enough. Other examples for unknown disruption levels are the so-called rages against machines. So sudden attacks of the helpless and innocent social robots. And then finally, there is the third example of disruption levels, the more subtle aspects of disruption that have to do with the designer dispositions, the social imaginary, the cultural imaginary that robotic designers often bring to their products. If you look at the picture at the left-hand side, interaction with a humanoid robot of a human shape sends certain signals that as such may be perceived as profoundly offensive. A little more subtle, at the moment we do not know whether humans will ever learn that social robots are a kind of item that you can be engaged with intensely emotionally at one time, but at the next time, the next moment, as you see that you can put that social other down, while with humans, who seem to be, where this interaction seems to be so similar, this cannot and should not be done. So right now, we don't know. We cannot really predict how robots will react, how humans will react, to the kind of robot that we, with our best intentions, are trying to put into some application space. And now comes the next problem. Values are particularly difficult to track. So when we have the best intentions of creating, say, a care robot that supports the value of autonomy and independence for an elderly person, we are entering a rather complex domain. So let's start with first ruminations here. Probably it's rather unlikely that you have engaged in questions like that. Are values actually real? Are they objective? Why on earth do we care about values? What do they mean to us? How do they function? How do they differ from motivation, from attitudes? Are there basic values? Are these universal? How do we rank values? How do we realize values? How can we investigate other people's values? Now, these are the basic questions of value research, and there are a couple of decades, in fact, 3, 4, 5 decades of value research in psychology, in philosophy, in the social sciences, and in philosophy, of course, centuries down. There's an enormous number of personal values. Here you have some. And equally, there is a somewhat lesser number, but also very different, sort of a very complex array of social values. Now, what one would wish as an engineer, I presume, is that we had some sort of a top-down, approach was possible, as you know it from other engineering goals. So there's first the aims of the enterprise, then there are sort of basic principles. From those you derive some operation rules and operating directives, and then some concrete rulings. So this kind of top-down approach that you can spell out for your goals, unfortunately, is not accessible for anybody working with human values, and in particular not for human values in interaction with robots. What one would need to do in order to find out which values an application can, in the first place, which values are addressed, which values can be preserved, which values can perhaps even enhanced by it, one would need to go through roughly 3 steps. First, the identification of the values. What are the relevant values in the given context for each of the stakeholders involved? And then comes the next step. How do they relate to each other? How can they be ranked? Catherine said before that ethical considerations arise when values are in conflict. And in fact, values are organized in hierarchies. And even these hierarchies can conflict. And when they conflict, there are interesting inversions of these hierarchies. And then the third step is the one that is the most complex one, where the entire team has to collaborate in order to find out what are the actual affordances of my robot. What does it need to do in order to support within the given context those values that I would like the people who are supposed to benefit from the application to experience. And just to give an idea of what one would need to do just for the first step, the identification of these values. That requires a whole bunch of methods that people trained in the humanities and social sciences actually have at their fingertips, a certain type of phenomenological sensitivity, tools that test the imaginative phenomenology of the people involved, certain definitions to understand which sorts of values are actually targeted by a user in his or her individual understanding. The relationship of these values in the context with the standards, and so on. So to figure out which values are involved requires a rather differentiated approach. Participant observations when people don't talk about the values but are just engaged in practices, and an interpretation of what these practices means. Questionnaires, yes, but in particular also interviews, video analysis, and so on. In addition, and that is the particular complication that I would like to draw your attention to, as I said before, certain interactions affect values that come organized in a value network, or some dominant values and others that are subordinate. How changes in interaction space change that value network? That is something that needs to be analyzed via several iterations during such an R&D process for a social robots. Give you an example. You might aim, of course, who wouldn't, that the application that you develop should preserve the dignity of, let's say, an elderly person who is supposed to use the piece of assistive technology or a companion robot or whatever you decide in the area, let's say, of care robotics. But dignity has is a rather complex value, and it has various dimensions. So it is, on the one hand, some sort of inalienable moral status, and as such, it implies at least 3 different dimensions of norms. And then, on the other hand, dignity is also something that we realize in our own comportment. It is something that others realize for us. and it is something that is written in the cultural, material, and institutional background conditions. So when one starts developing an application here, one needs to very carefully consider which of the vulnerability aspects associated with each of these readings of dignity will my robot actually affect? Which should it respect? Which should it support? And here you have, of course, we cannot go through that, but just to give an impression of the complexity of the research that needs to be done there for all the different dimensions, emotions, cognitions, agency, and so on. That has to be spelled out. The issue is very much complicated by the fact that not only we have in each social interaction 7 perspectives. So it is not only what the user actually thinks is happening in the interaction with the robot. It is also what the robot, how the robot is, of course, programmed to respond to that, which kind of user experience the robot is supposed to support. But in addition, and that is the tricky point, there's always the 7th perspective, namely the perspective of society at large, the outside observer, whose interpretation and recognition for what is happening in human-robot interaction is very decisive for the value experience. And that, to analyze the social norms, ethical norms, value conceptions of society, that is another aspect of the expertise of humanities and social science researchers. That's what we are good for. So I hope that by now you have seen the second element of my provocative argument. Values are so difficult to track because they are contextual, hierarchical, and dynamic, and social interactions are particularly complex. So what one would need in order to perform the first step is we would certainly need methods of qualitative research. But in order to perform the first and the second step, but in order to perform the third step, in addition, what is needed is a very fine-grained description framework to capture the experiences of users and observers of human-robot interactions in a particular application space. These were the motivations for our work on such a framework. We call it the OASIS framework, where we distinguish 10 levels of sociality, that is the way in which you experience the coordinative capacities of the item that you are interacting with, and therefore have a phenomenal experience of sociality of a more or less sophisticated level. We don't know and don't have the time to go into details here, but these are just different coordination levels. And to work with an example, think of how you experience your interactions with a cat as opposed to a human, as opposed to a small child with 3 or 4 years. There you see that the sociality experiences that you have in each of these situations has something to do with your expectations of coordinative capacities. So when people experience their interactions with social robots, we could show that some of these different levels are involved, but it also matters how well the robot simulates any of these coordinative capacities. So we distinguished 5 modes of simulating. Again, the details don't really matter for us. What matters for this particular purpose is I would like to remind you of the fact that we are not only caught in the Collingridge dilemma, right? The famous dilemma that we're putting something out into social space, a kind of technology that we can no longer extract at the point where we see already the consequences. So that's the Collingridge dilemma. We do something, we don't know the consequences, and when we see them, it's too late to extract, to undo what we have done. Social media, perfect example. But we are actually caught in a much more profound more profound gridlock here between regulation, description, and evaluation, because we don't quite know yet what it is that we are doing. We have no tools to describe it properly. That's why the evaluations that we get from human-robot interaction research are not yet compoundable. They don't yield the sort of reliable research input for regulation that we would wish for. So in this situation, we suggested what we need to do is simply work together, and that's what we call integrative social robotics. The current approach is that the roboticists work very much by themselves. There's human-robot interaction studies that gives input. The policymakers call on ethics committees, but essentially what is dropped into human interaction space is an object, a robot. And in contrast, what we suggest is that we need to include the humanities expertise from the very beginning. This will also make everybody's life so much easier, because now the humanities researcher will provide all the justificatory moves. They have all the expertise in order to argue, for instance, in the B case, Catherine's B case, that the so-called principle of double effect from ethics might be applicable to justify why it is possible to use the robots here. Yeah, so the involvement of the humanities researchers from the very beginning, that is our approach here, challenge continuously the ethical dimension of the application, but not only challenge it, but also assist you in all sorts of ways. Help you to identify these values, to trace the tracking, help you to track it, to trace the dynamics of the value hierarchies. This is very roughly a flow diagram, and as you can see, it looks in many ways rather familiar with iterations and so on. But what is important is that at the very beginning, there is this careful value and sociality analysis of the context. Social robotics is not an area where the ethical intuitions of the robotics engineer are enough. And that is perhaps a bit of a frustrating thing to say, but also the ethical intuitions of the philosopher or of the psychologist, the social scientists are not enough. The only way in which we can handle the rather complex space here, the rather confusing array and possibly trajectories towards either just functional social robotics, which is not human-centered, or the two routes of human-centered approaches, namely value-preserving, that's what we call culturally sustainable, or even positive value-enhancing. In order to find out and find our ways through these trajectories, we need to collaborate. So in sum, I hope to have presented at least a plausible argument, and hopefully also one that we can discuss later on in greater detail, that rests on the following claims. I hope to have made plausible that social robotics carries special risks and potentials, since social robots are no longer robots. So functionality and safety considerations, as incredibly important they are not we cannot stop there. They are not everything. We need to add a very important additional dimension, namely the effects. We need to investigate how humans experience their interactions with these new types of social others. So there are responsibilities that we can only discharge together, putting all the available expertise together. In particular, because value experiences are about the most subtle target one can focus on in social reality. They're particularly difficult to track. And for that reason, I think our hope is only, as I said, collaboration with those people whose education is precisely designed to address ethical dilemmas, inversions of value hierarchies, and in particular, the very, very fine-grained analysis of what it is that makes humans happy, or at least doesn't make them unhappy when they interact with a new piece of technology. And that's what I had today. Thank you.
Thank you very much, Johanna. That is a very exciting talk. I would like to just ask a question related to the attribution effect, the fact that when we interact with social robots, by the way, not only social robots, we attribute to them capacities, features that are more or less human-like. And I was wondering if the framework that you have very clearly presented to us, and which is really important, I think, does it in a way encourage this attribution? Yes.
Yeah, that's a wonderful question, because what we found to our amazement is that HRI research largely proceeds from the assumption that we anthropomorphize social robots, and it is really questionable whether we do that. So we coined the new concept sociomorphing. And the reason why we want to distinguish all these different levels of sociality is that we found that people do attribute some social, they can't help due to the sociobiological mechanisms in our brain, they can't help attributing to robots certain social coordination capacities, but these are far below the human, or can be at least. And so a particular interesting design goal that we are pursuing right now is what we call minimal social agency. So it should be just enough that it is feels trustworthy to interact with this agent, but at the same time is not in the vicinity of a human being. So that's precisely, I think, one of the advantages of working together here is that we can define new design goals and explore the entire space of human reactions to robots.
Thank you. Are there any questions to Johanna? I don't see hands raised. I don't see anything in the chat, and it's about time to move to the third speaker. Thank you, Johanna, again. So, Alan, you have the floor.
Thank you very much indeed, Raja, and thank you especially to Catherine and Johanna for those extraordinarily deep and interesting presentations, so which I really, really very much enjoyed. Thank you. So I'm going to be, and of course I'm aware that I'm an engineer, but I'm going to be offering a tool that I hope you might consider using in your various projects called ethical risk assessment. Let me just go to full screen. So I'm really going to be talking short talk, only 18 slides, I think, in two parts. Firstly, I'll introduce a new standard, which is a method for ethical risk assessment. And secondly, I'll give you an example of how to do ethical risk assessment. So risk assessment, of course, in engineering, and I'm the first 10 years of my professional career was spent in industry building safety critical systems. And of course, risk assessment is a part of all engineering practice. And here are a couple of current standards in risk assessment. 14971 is risk assessment for medical devices, and 12100 is a more general risk assessment and risk reduction of machinery generally. So risk assessment is not new, but the British Standards Institute, and as Raja mentioned, started an ethics initiative back in about 2011, 2012, quite early in the story of robot ethics. And we started writing a standard, this standard, which is a BS 8611. In fact, it was published in 2016. And we believe it's the world's first technical standard that actually has the word ethics in the title. It's a guide to the ethical design and application of robots and robotic systems. In fact, the standard was just last year updated. So the latest version is now 8611 2022. Standards are living documents. They're not static. So what is it? Well, as you might have guessed, 8611 is a method for doing ethical risk assessment. So what is ethical risk assessment? Oh, what is the standard? Well, it basically, the standard sets out 20 distinct ethical hazards and risks. I think the number has grown a little bit in the second version, but and those are grouped under 4 categories. So there are societal risks, hazards and risks, application hazards and risks. You could say those are risks to the individual, commercial and financial hazards and risks, and environmental hazards and risks. And for each one of those distinct hazards and risks, the standard gives advice on how to mitigate the impact of the risk, and also suggestions as how you can perhaps verify or validate the mitigation. In other words, how can you show that you've actually improved or reduced the risk of harm? So this is how 8611 defines harms, hazards, and risks. A harm is that which, an ethical harm, that's very important, the word ethical. An ethical harm is that which might compromise psychological and or societal and environmental well-being. An ethical hazard is a possible source of ethical harm, and an ethical risk is a possible ethical harm arising from exposure to the hazard. I mean, this sounds a bit formal, but standards are, of course, they're not legal documents, but they are written in a kind of quasi-legal way. The language is very precise in standards. So here are just a few examples and I've just picked these at random from BS 8611. As I say, there are 20 of these, but I've chosen 4 of them. Deception is the hazard. The risk is a risk of the user of the robot being confused. There might be unintended or possibly delayed consequences. One of the risks is loss of trust in the robot. And of course, what this is, we're talking about the user being deceived into thinking that the robot perhaps is a person, or is alive, or has feelings for the human. So that's, deception is quite a broad scope of possible hazards here. And the mitigation would be to design the robot behavior and appearance to avoid deception, and to make sure that the nature of the robot is transparent. In other words, it's you know, it should, for instance, look like a machine, not like a person, according to this logic. Johanna, of course, spoke about anthropomorphization, and the risk there is interpretation. And again, we want to avoid unnecessarily human-like design. Anthropomorphization is very linked to deception. A more conventional hazard is privacy and confidentiality, or loss of privacy and confidentiality. And there we need data control, we need justification, clear justification for data collection, user awareness, transparency, informed consent, all of those good things. And we also have addiction. And this is where a human might become overly dependent on the robot, and perhaps have a reduced willingness to engage with others, or possible isolation. So these are some interesting, I hope you agree, interesting risks. But of course, risk assessment, as I mentioned already, is a well-established process. Of course, ethical risk assessment is not new either. Ethical risk assessment is what university research ethics committees do. So the idea of ethical risk assessment is not a new idea, but the idea of using ethical risk assessment for robots is a new idea. This is the the standard. But essentially, risk assessment is a well-established process that identifies and analyzes potential events that might cause harm and so on, and makes judgments on their acceptability and the impact of the harm arising. And you typically might, for each of those possible hazards and risks, you might well assign a level, in other words, low, medium, or high. And risk assessment is certainly a part of responsible innovation. I think it's an incredibly powerful tool. And really, ethical risk assessment really just takes conventional risk assessment, which is very well established, and enlarges the envelope to cover all of those additional risks, the psychological risks, the societal risks, and the environmental risks that go beyond safety. Typical, conventional, old-fashioned risk assessment is concerned with physical safety. Ethical risk assessment goes far beyond. And I've come up with, I used to work on safety critical systems, and I like to think in terms of ethically critical systems. So a safety critical system is a system whose failure could result in death or serious injury, loss or severe damage to equipment or property, or serious environmental harm. So we could extend the envelope of safety critical systems to include very serious ethical risks, such as exploitation of emotional attachment to a robot by an unscrupulous manufacturer. That would be, as far as I'm concerned, an ethically critical risk, and so would misidentification as a result of weak facial recognition. So it, in a sense, the metaphor of safety critical systems, I believe, extends to ethically critical systems. So I'm now going to give you a worked example. This is an example based on a fictional robot. Actually, the robot was inspired by Roboted in well, I think it's wonderful anyway, the movie Artificial Intelligence. The director was Steven Spielberg. And I think it's a remarkable movie because of all of the thought experiments. There are many, many thought experiments played out in the movie AI. But Roboted is an amazing robot. So our Roboted isn't as capable as the movie Roboted, but essentially it has the following technology. We're assuming the robot is an internet-connected device. It has cloud-based speech recognition and a conversational AI or a chatbot behind it and local speech synthesis. We're assuming that the robot has functional cameras. Its eyes are functional cameras allowing facial recognition, and it has motorized arms and legs to provide it with limited kind of baby-like movement, crawling perhaps, but I mean not walking around, not perambulating like the movie Roboted. Now, what can it do? And again, we need to know this if we're going to do an ethical risk assessment. Well, in this fictional example, Roboted is designed to recognize its owner, learning their face and name and turning its face, for instance, towards a child. In fact, robots that have that capability already exist. They're, as robot toys, smart toys, to respond to physical play, such as hugs and tickles, a bit like the Paro robot that Johanna showed. Tell stories, again, while allowing the child to interrupt the story to ask questions. This actually would be an easy facility with chatbot technology as it currently stands. Sing songs, encouraging the child to sing along and learn the song, and act as a childminder, allowing parents to both remotely listen, watch, and speak via Roboted. So those are a set of functionalities that you might imagine a bunch of engineers without any support from people from the arts and humanities might think they're a great idea. We'll build this Roboted and we'll put it on the market. So this is our ethical risk assessment, and it's not complete. I mean, this was prepared for a conference paper, but it's indicative, if you like. And addiction, not surprisingly, is present. We've identified this as a medium level risk, and the risk is that the child plays with the robot obsessively and neglects their family. And a simple mitigation strategy would be to explore a Roboted needs to sleep function. So in other words, the robot, after a certain 20 minutes or half an hour of play with the child, the robot says, I need to go to sleep, and goes to sleep. Deception. So this is the deception of the child believing that the robot has feelings for her, for the child. And here we need to design the chatbot to avoid language that suggests feelings. Obviously, in my view, at least, it would be quite wrong to have a robot that says, I love you, or something like that. When, robots, even though they're not robots, as Johanna very eloquently explained, cannot love. They cannot have feelings for humans. And then we have over-trusting by the parents. And this is where the parents come to rely on the childminder function. We think this is a very high risk. And the mitigation suggested in the paper is to remove that function entirely. And, it's important to understand that ethical risk assessment isn't just a moderation exercise. It's an exercise in deciding what things should not go into the final product. The uncanny valley. This is perhaps a marginal risk. The idea that the child becomes fearful of the robot because it's a bit too uncanny. Actually, we think this is very low risk because children, of course, are used to teddy bears. Teddy bears are a familiar toy. But perhaps we need to use a cartoon voice rather than a very human-like voice. A cartoon voice perhaps would mitigate any risks of the fearful reaction of the uncanny valley. Then our second group of risk assessments is around privacy and transparency. There is obviously a hazard of weak security. It's a high risk. And the risk there is that malicious hackers gain access to Roboted sensors and control functions. This has already happened. I mean, some years ago, this happened with internet-connected baby alarms that hackers got in and you know and were able to cause distress, if not harm. So the mitigation here clearly is that we need strong encryption together with best practice password protection. Privacy, well, of course, there is a risk of personal data, including images and voice recordings, are stolen. And what we need to do here, and we think this is a medium level risk, put in place auditable measures to ensure that personal data is deleted immediately after it's been used. The cloud doesn't need to store those conversations. We only need the cloud to actually do the processing, but we don't need to store those actual interactions. And finally, a lack of transparency, and in particular, a lack of data logs, would make it impossible to investigate accidents. And this is a high risk, and I'm particularly hot on accident investigation. I have a current UK project researching robot accident investigation. And here we need to build a secure local data logger, kind of the equivalent of a flight data recorder that of course commonplace in aircraft and many other physical systems, should be built into the robot so that if there is an accident, we can actually figure out what went wrong. Without that data, it would be almost impossible to understand what went wrong in the event of an accident. And that's just 3 groups of hazards and risks that we identified. And what I think I've shown you is that the attention to ethical risks can suggest new functions, such as Robo-Ted needs to sleep now. It can draw attention to how designs can be modified to mitigate risks. It can highlight the need for user engagement, and that is, you know, having children as part of the, if you like, the trials process, and families, not just children, families. And of course, can even result in product functions being rejected as too risky. And, you know, we've only sampled in this paper a subset of ethical hazards and risks. Really, we need to look at all risks guided by BS 8611. Now, it's interesting that even in this paper, there are risks and hazards that are not identified in BS 8611. It would be impossible to write a comprehensive, you know, 100% comprehensive set of risks and hazards. So it really does depend on the design team and the people they're working with. And, you know, this is very important. Ethical risk assessment, powerful though it is not guaranteed to expose all ethical risks. And I really like this quote from Shannon Valor and her team. This paper writes, design teams must develop a habit of exercising the skill of moral imagination. And this really reflects very strongly on Johanna's really wise advice.
Please put me in copy if you don't mind, Rika.
On needing
no, it's John.
Needing you know, people who can really look at the values and kind of brainstorm, if you like, the values. Here we need to brainstorm risk, and it needs a broad cross-disciplinary approach. So that's it, I think. So thank you very much. I've given links here to 2 papers. The paper that this presentation is based on, which you can find on Archive, and there's a more recent paper that we published in an edited book. This more recent paper, in fact, includes a second robot, which is a real smart toy. I've not included it in this presentation because actually the robot is very simple, and it's, you know, the ethical risk assessment I think is perhaps less interesting. But thank you very much indeed, and I hope you find that interesting.
Thank you very much, Alan. So let me ask you a brief question.
Mm-hmm.
In your standards, actually, the ethical risk assessment goes beyond safety, and this is also something that we found in the previous presentations. The safety is the first thing that comes to mind when you develop a robot, but here clearly safety is not the main issue, and it's not the issue at all, actually. And this is why it's important for robotics researchers who are usually focusing on safety to broaden their perspectives. But my specific question, then we can move to other questions and discussion, is the certifiability of the standard. How is there a process that enables to make sure that this standard has been indeed followed and implemented in a system?
The short answer, it's a good question, is no, because essentially there are no agencies that do the, if you like, the audit and issue certificates. And of course, it's a property of all standards in the world, every single one of them, they're voluntary. Now, some standards are not really voluntary, because if, you know, there are thousands of standards that apply to the design of an aircraft. And of course, you cannot fly an aircraft legally without approval from the Civil Aviation Authority or your national, you know, aviation authority. And that means that the standards that the regulatory body require are, in a sense, de facto. I mean, you know, it is de facto illegal to not apply the standards. Now, that doesn't typically apply to new standards, and of course, a standard published in 2016 is still a new standard. And particularly this new raft of ethical standards, including the IEEE standards you mentioned, none of them, I mean, a number of the standards, particularly the 7000 series standards you've mentioned, have been cited in, for instance, discussion documents, both, you know, for the EU AI Act and for proposed or at least discussion documents for the UK Parliament. So in a sense, that's the first step. But I think that what doesn't exist yet is a kind of industry, could be a cottage industry, of independent auditors who would offer as a service auditing the ethical risk assessment. And bearing in mind that ethical risk assessment, just like values considerations, as Johanna explained, it isn't a one-off process. It's a continuous rolling process. But at some point, you know, there will be, I think, consultancies who would, you know, for a fee, do an audit of the process of ethical risk assessment, and then, you know, offer, in a sense, a kind of it's not a legally binding document, but the point is that it's you know, offer a judgment of the quality, if you like, of the ethical risk assessment. Sorry, that was a long answer, but
thank you very much. So I see a few hands, and so please, I'm going to give you the floor. You can address any of the speakers, of course, or you have general comments. So the next hand I see raised is Mohamed. Mohamed.
Yes, thank you for the presentation. I have it's to you, Alan, but I mean it's also related to Johanna and Catherine. I like the way, I mean, it's related to Robotics, basically. It's a good way of addressing, to give examples to people, and I think it's valuable. And I have, let's say, one question in two. The first one is, do you mind if we use your model, your example in other situations? So that's a point. And the second point is, what do you think about having that? Because in AI, having baselines and having people are used to have examples and to compare. But here it's different. We don't have models but I think it's valuable to get that, and so it's one of my first question is about that. And second one is related to the example. Should we add something, because if we have to use the robot head, this will be in particular for euROBIN and project. If this will be an experimental, let's say, so this means that we should add other stuff in the example, like how we introduce the robots to the people, how we take the consent, but also how we finish the experiments, for example, and how we can. So how you see that? So my question is more about examples. Could we use them and try to extend them and maybe share between us these examples? And what is the role of this?
Thank you, Mohamed. And I mean, so to your first part of your question, yes, please. I mean, and in fact, I forgot until right now that at ICRA this summer, we also had a new paper, another paper, a third paper on ethical risk assessment for a completely different kind of robot, for a hospital disinfectant robot. So that gives a third example. And I think the more examples, worked examples, the better. And I would say, please do, and please then, of course, cite the papers and the standards. As for going beyond, yes, absolutely. And in a way, I mean, if your research project has human participants, then you will be required anyway by your university to go through research ethics. And research ethics, the research ethics process requires you to do, in a sense, a self-assessment of risk. And typically, a research ethics committee will come back to you with questions and will challenge, you know, and of course they're looking for an envelope of risk assessment that includes the manner of the project, the way that you're starting, as you say, the way you're finishing, what you're doing with the data that you collect. All of those things are required, and you're quite right that those go beyond the standard set of risks that are set out in BS 8611, because those are essentially focused on a product. In other words, a robot or a robotic system, whereas you're concerned, quite rightly, with an entire project. So yes, and yes are the answers to your very good question.
Thank you, Alan. Thank you to all of you.
Thank you, Alan. Brendan, please, when you have a question, introduce yourself, just mentioning, for example, your affiliation. Thank you. Brendan?
Hi, yeah, my name is Brendan Baltarak-Jackson. I'm working with the Joint Research Center for Cooperative and Cognition-Enabled AI in Bielefeld and Paderborn and Bremen. It's a kind of a network. So hi to everybody. Thanks for the 3 talks. I just had a quick question, partly for clarification from Alan. When you were going through your example and you were assessing the level of hazard in each case, low, medium, high, and stuff, is that an assessment of how likely that risk is, or how bad it would be if it happened, or some kind of mixture? And in either case, how do you measure that, or how do you?
Yeah, I mean, that's a good question. Again, it is really a mix of both the likelihood and the severity of the consequence. So if it's likely and has a severe consequence, then I think it's high. The less likely the risk, then it even though there's a high consequence, if it happens, that might reduce it to a medium level. I mean, like all of these things, I mean, ethical risk assessment is not a scientific process, and I say that as an engineer and a scientist. It is a human process of evaluation, of iteration, of thinking, brainstorming, kind of radical brainstorming. So yeah, matter of judgment.
Good, thank you.
Thank you. Catherine?
Yes, thank you. This is a small question for Alan. Thank you very much for a very inspiring talk. Isn't there a tension between deleting the personal data and all that stuff and keeping some evidence for in case of accident?
Yeah, the short answer is yes. And within the project that I currently have with the University of Oxford here in the UK, called Robotics, we're exploring exactly that kind of dilemma. There is a kind of middle pathway, though, because in a sense, you need to. Well, I think actually there are. Come to think of it, there are a couple of parts to the answer. The first is that typically robot accident investigators in general, and of course, we've got to know quite a few of them who've become affiliated with the project. They're always subject to confidentiality. So the point is that the data that's shared with a robot accident investigator, and this is the same whether it's a train crash or a plane crash or whatever, that data remains confidential. So the question, of course, is which of it should be deleted, and again, that's a judgment, I think, for the design team. Well, for the design team together with the larger constellation of advisors and stakeholders, the stakeholders involved. And of course, the lawyers may well be involved as well. I mean, they're often stakeholders too. But, certainly from we've been conducting a series of mock accident investigations as part of the project, which are fascinating, absolutely fascinating, because of course, accident investigation is a human process. And even though the data from what we call an ethical black box is essential because it's the ground truth, ultimately far more important is the testimony of the human witnesses, the subject of the accident, the witnesses to the accident, even the people who are not there but are familiar with the environment, the care home, the context, and the manufacturers of the robot. So like most things in life, actually, it's the human part of the accident investigation that is more important in a way than the ground truth. So even if there are bits of data, for instance, the actual some of the text has been deleted, the fact that there was a conversation going on may well be enough, as opposed to the precise conversation. But it's a tricky question, and in my view, if an elderly person has an assisted living robot, and if that robot has a data logger, which I believe it must, then the user has the option, I think, of deciding how much personal data should be kept and how much should be deleted. And of course, ideally, the human, the elderly person or their family, perhaps both together, need to understand that the more personal data you require or you request to be deleted, then it may well be harder to find out what happened in an accident. Yeah. So as long as that's understood and transparent, I think then the humans who are using the robot can make that decision, make an informed decision about that trade-off. Great question, though. Thank you.
Thank you. Johanna?
Thank you. Yeah, I have a question, probably also for or comment, further elaboration for Alan and Catherine together. I am, as I was listening to your talk, Alan, I thought there is the phenomenon of Don ID called multi-stability. That is that whenever you develop a technology, you cannot really predict how it will be used. And that holds already for functional robots and tools and so on. But it is even much more dramatic for something that is so much, where the use is so much dependent on individual dispositions and biography and context and so on. And so I thought the ethical risk assessment, it's a fantastic heuristics, right? It is something that, from my point of view, the multidisciplinary team should use at the beginning of the R&D process as a guide for the field research that comes at the beginning, then throughout, again and again, many iterations, should use again about after 3 months and then again 6 months of placement of the robot to see what has happened now, right? So it's a wonderful tool, but also, as you sort of emphasized, it is very important to think of it as an instrument for letting human judgment, ethical judgment, actually become active. And here's a question that I have for Catherine, and that is maybe for both of you, how do we need to think the temporal dimension into the question that is on the table right now, namely ethics in social robotics and so on? How do you see that? For me, it's extremely, this is a very extended process that begins, as I said, at the very beginning of the R&D development and then goes on long after the first placement. How do you see that?
Yes, thank you, Johanna. I would say it should begin before the R&D, the beginning of the R&D process. As soon as you have an idea of a project and you begin writing the project and submitting it to Europe or anywhere, you have to think about those ethical issues that are going to be at stake, and then rethink about all that during the various steps of the project once it is accepted at the very beginning, and then as soon as you develop new concepts and so on and so on, and then even after the end of the project, well, and assess whether this project or the results of the project, are they going to be used in the real life by the industry, and for which purposes? Are those purposes, do those purposes match to the purposes of the project, or are there other uses, and what are the responsibilities of the researchers if their techniques, their results are used in a way that was not planned during the project. So this has to be thought about at every step, in fact, of the project, and even before and even after the project. But that's a bit difficult because, as I don't know, I think said, or you, I don't know, I can't remember. In fact, scientists and research engineers and researchers are not really trained to do that. So that's the main issue, in fact.
Yeah, that's why we need the multidisciplinary collaboration, and really the interdisciplinary teams for that.
Yes, I absolutely agree with Johanna. I mean, this needs to be an ongoing process, an iterative process.
Yeah.
And, you know, in the broader context of ethical governance, you know, I've been advocating that a particularly high impact robotic systems. You know, I was in Brussels just a couple of weeks ago for a meeting, a workshop on systems that have self-awareness, and you know, I was suggesting a framework for ethical governance, and I think it's really important when you have very advanced technologies that you know, even if you only suspect that they might be self-aware, then you should be having a sort of what I call a probationary period, during which an expert panel will be reviewing all of the decisions that the robot made, and looking for, you know, areas of concern. And then even after that, you know, assuming that the robot you know, is considered to be satisfactory, it's not giving rise to unexpected consequences, or at least, you know, unwanted, as it were, negative unexpected consequences. There might be positive ones, but even after that probationary period is finished, you should still have, you know, every 6 months, 3 or 6 months, a kind of spot review, especially if it's a system that learns, most especially if it's a system that learns. So, you know, I think this kind of iterative process is super, super important.
And again, there is a difference between increase in knowledge, for instance, as far as the beeRobot project is concerned. Of course, it will increase knowledge on many fields. And using the results, that's two different things.
Yes.
You can increase the scientific knowledge and assess that the results, well, perhaps it's better not to use them.
Yeah, I'm very grateful, Catherine, because I mean, I know most of the people on that project very well, and I'd not come across the project at all, but I've worked with Thomas Schmickel and his team, and also Farhad and Thomas Kranich, and you know, I know those guys very well. Yeah, they're very good. I mean, they're brilliant scientists, I have to say.
Yes.
Yeah.
I have a question to you all, maybe starting with Johanna, because she mentioned values, and her speech was also related to that, and she gave us a great presentation about what values are, etc. So the question is, when we design a system and we have these issues about values, who should take responsibility about deciding priorities among values? So you said it's contextual, hierarchical, dynamic, yes. But at the same time, you are designing a system, and the tensions between the values, it was also mentioned by Catherine and Alan, the tensions between the values are very common, and all ethics deliberation is about deciding what to do for resolving these tensions. So who should take responsibility about this? The expert designers, even if you include social science and the humanities with them, they are also expert in their domain. How do we consider other stakeholders?
Yeah, I mean, here again, there's a question that, Raja, your question is partly, do we have already the right responsibility models for that? Because our current responsibility models are very individualistic, and we're only starting to develop targeted models of collective responsibility. That's one question. And the other one is sort of more targeted for which type of application, who should take responsibility. And we have been discussing the question with focus on the use of robot in public institutions. So, you know, nursing homes, hospitals, and so on. And here it must always be, that was our assessment, it is always a form of shared responsibility. And that's one of the collective responsibility models that not only the experts, but also the public institution that has its own rules for how the new technology is to be used, and actually also has responsibility of ensuring of a longer period of time with direct supervision that the robot is used in the right way and so on. So we talked about the auditing before. I think the auditing process needs to be iterative, but the responsibility model that is used for that kind of auditing must be one of shared responsibility, where you actually divide very clearly but concretely for the context, who is responsible here for what. Yeah. But I must admit, I have no good answer for what to do with the fictional robot head. If we talk about commercial robots, I mean, for individual use, here I think only the old model that technological literacy will help the individual user or buyer discharge his or her own responsibility. So it would be the parents' responsibility to use that, to buy that robot, or you know, setting it up, how to use it, they have bought it, and so on. But society would need to ensure that the parents really are given all the information that they need in order to make an informed decision. So I'm sorry, it's you know, depends answer. It kind of depends answer.
Thank you. Maybe Alan, you have.
Sure. Yes. So I mean, I absolutely agree. In fact, I think it depends. You know, the extent to who should bear collective responsibility depends very much, I think, on the level of risk. So, for instance, you know, there's been a lot of debate about, well, it seems to have died down now, but 3 or 4 years ago, there was a huge debate on whether driverless cars, autonomous vehicles, should make moral decisions. Mm-hmm. Now, personally, I think it's a very bad idea. Mm-hmm. But I've definitely written somewhere that if we should find ourselves in the position where autonomous vehicles are, you know, do have logic built into them so that they can choose between two different, both, you know, disastrous outcomes, then I think it's very important that the whole of society, not just a little bit of society, not just lawyers, not just, you know, insurance companies, but the whole of society should agree on what those rules are. Because in a sense, you know, if you have robots that are facing dilemmas where, you know, even the least worst outcome still causes serious harm, then I think society collectively needs to own that decision, even though the decision is made by a machine. Mm-hmm. So I think, you know, I think a lot depends on the, as it were, the criticality of the system. And, you know, as you say, Johanna, you know, it even for toy robots, smart toy robots, there needs to be a level of collective understanding. I'd say if it's a more critical system like a driverless car, there needs to be collective responsibility, not just collective understanding.
So in this case, do you think that it should be enshrined in law? Because if it's, when you say society, it means some authority has to actually make sure that there is compliance with this general decision.
Yeah, I mean, typically, what would be ideal is if legislation is being written that in a sense reflects this kind of moral decision making built into a machine, then that's something I think that should go to a referendum. Now, I mean, some countries, of course, Switzerland has referendums every other week, but some countries, particularly the UK, don't like referendums, and they often give the wrong result, like Brexit. But I mean, ideally, and that's what we're talking about, I think such decisions should go to referenda before the legislation is enacted, is made into law.
Thank you. We are about to reach the end of this workshop. Maybe some last comments, Johanna, Catherine?
Okay, I go. Here's the message to everybody who's listening and who has not raised his or her hand for a comment. If you have any questions, of course, I take it that all three of us are more than happy to continue the conversation. But for my own sake, I just want to say, whenever I find in interaction with engineers, computer scientists, there is this frustration about our talk being so vague, so relative. Everything is contextual, nothing is certain. And from the epistemic habits that you have, you want the secure standards, you want the on-off decision mostly. So I just want to send a message here. I understand the frustration if you have any, but unfortunately, the technology that you are developing are now so smart that you have yourself catapulted into a realm where you have to endure that, where you suddenly have to engage in all these complicated considerations.
Thank you very much. Catherine, any last words?
Yes, just a few words in the same sense as Johanna. Somebody does not need to be an expert, again, I say that, to be an expert in ethics or whatever, to begin an ethical thought. So everybody can do that. And well, of course, at the beginning, you won't have exactly the tools, but it comes with practicing. Ethics is something that you need to practice, and it's not written in books. And well, so please practice this ethical thought and just ask questions about your work and question the results, the methodology, and the possible outcomes, and etc. And that's everybody can do that. Every scientist can do that, in fact. Yeah.
Thank you again. Thank you all for attending. This meeting, as I said, has been recorded, and we would like to make it available on the euROBIN website later on. And there will be other workshops about ethical issues in the future, so please stay tuned. Thank you very much for attending. Thank you to the speakers. Thank you.
Thank you.
To act as our ethics committee. Thank you.
Thank you very much for everybody attending. Thank you.
Bye-bye.
Bye-bye.
Bye-bye. Bye-bye.
Thank you a lot. Bye.
Thank you. Bye-bye.